All right, let's get right into it. We're talking about something that honestly sounds like it's been ripped from the pages of a sci-fi novel, creating liquid fuel, the kind you can put in a jet using pretty much just water and the air all around us. I mean, just think about that for a second. Could you really power a jumbo jet with water and air? It sounds completely out there, right? The whole idea of taking the very greenhouse gas we're all trying to get rid of, carbon dioxide, and turning it into high-energy fuel.
Well, here's the kicker. It's not science fiction anymore. Scientists in Japan have actually done it. They've made it a reality. But, and this is the big but, in doing so, they've run smack into the real problem. The science works, but can anyone afford it?
So what is the secret sauce here? How in the world do you turn air into oil? Well, there's a name for this technology, and it's really at the heart of this whole discussion.
It's called synthetic fuel, or you'll often hear it called e-fuel, and the basic recipe sounds almost simple. You grab some carbon dioxide, you can snatch it right out of the atmosphere or from a factory's exhaust. Then you get your hands on some hydrogen, which you get by splitting water molecules using clean, renewable energy. You combine those two, and boom, you've got a liquid hydrocarbon that works just like the gasoline or jet fuel we use today.
So why is this such a big deal? I mean, we've got electric cars. That's great. But you can't exactly plug in a giant container ship crossing the Pacific or a 747 on a transatlantic flight. That's where e-fuels come in. They offer a potential path to decarbonize those massive industries that just can't run on batteries. It's like creating a closed carbon loop, recycling the CO2 that's already out there instead of drilling for new fossil fuels.
And look, this isn't just a theory being tested in a tiny lab. The Japanese energy giant ENEOS went all in and built a full-on demonstration plant to prove that this whole process could actually work on an industrial scale. The engineering behind this is just fascinating. First, you need a ton of clean electricity. That's the foundation for the entire thing. Second, you use that power to run a process called electrolysis, which is basically a fancy way of saying you zap water to split it into hydrogen and oxygen. Finally, you take that hydrogen and your captured CO2 into a reactor, and you use some pretty well-established chemistry to stitch them together into the long chains that make up liquid fuel.
And this is what it actually looks like. This plant in Yokohama was a first of its kind in Japan. They managed to take all those different steps and string them together into one continuous flowing system. That in itself was a massive engineering accomplishment.
And then, in 2024, they had their big moment. They produced the first drop. It might sound small, but it was everything. It was tangible proof that they had done it. They had successfully made oil from water and air in a system that was built for industry.
But you knew there was a but coming, right? The celebration over that first drop quickly gave way to a much harsher and way more expensive reality.
Get this. The plant's total output was 1 barrel of fuel per day. Just one. Now, that's a monumental scientific achievement, don't get me wrong. But in the grand scheme of global energy demand, it's literally a drop in the ocean. And the ambition here was enormous. The plan was to scale up from that 1 barrel to 10,000 barrels a day by 2040. That really highlights the colossal gap between a successful test run and a commercially viable operation.
And then came the shocker. In 2025, ENEOS paused the project. They just stopped. After proving the science worked, they hit the brakes. And the big question, obviously, was why?
Well, it wasn't because the science failed. It was all about the economics. The process demands a mind-boggling amount of electricity, which makes it incredibly expensive. The cost of making green hydrogen was also going up. And frankly, there are other more mature alternatives out there, like biofuels made from used cooking oil, that are just a cheaper and faster way to cut emissions right now. But the story doesn't end there. Just as the big industrial approach seemed to hit a dead end, a brand new breakthrough came out of the academic world, and it offered a potential fix for one of the biggest bottlenecks of all: speed. You have to see this to believe it. Researchers figured out a new catalyst that took a key part of the conversion process and slashed the time from a full 24 hours all the way down to just 15 minutes. Now, that's not just a small improvement. That is a fundamental, game-changing leap in efficiency. So what's the magic ingredient? It's a low-cost material called cobalt phthalocyanin, which, believe it or not, is actually a common blue dye. You can just spray it on, no complex high-energy heating needed. The real genius is how it works. The spray creates this perfectly ordered crystal structure.
You can think of it like an 8-lane superhighway for electrons, letting them zip through and speed up the chemical reaction like never before. It's faster, cheaper, and more stable, and it could completely rewrite the economic equation for e-fuels.
So, with these huge challenges on one hand and these incredible breakthroughs on the other, it's really important to zoom out and see where synthetic fuels fit into Japan's bigger picture for a carbon-neutral future.
The truth is, synthetic fuels are just one piece of a very, very complex puzzle. Japan's 2050 plan is really an all-of-the-above strategy. It relies on renewables, of course, but also on hydrogen, nuclear power, and massive carbon capture projects. E-fuels have a role to play, for sure, but they're clearly part of a much larger portfolio of solutions.
And they also have some stiff competition. Biofuels, for example, are a much more mature technology. I mean, Japan Airlines is already flying jets using sustainable aviation fuel made from things like used cooking oil. So that's the tough trade-off companies are facing right now. Do you invest in the long-term, high-potential promise of e-fuels, or do you scale up the more immediate, market-ready solution like biofuels?
Which leaves us with the ultimate question. We know it's possible. The ability to create fuel from air isn't a theory anymore. Japan proved it can be done. The challenge now is a race between technological innovation trying to push the cost down and the urgent ticking clock to decarbonize our world. The science has officially arrived. The only question left is, can the economics catch up?